Okay, now here a little bit the story about math in the past, in the very 1,000 years ago. So we applied the Auckland formula to see how powerful, the people in the past, the Maya people in the past here. Very soon after people think the Earth's round, right? So in Egypt, in Cairo, the mathematician put a stick right here, right in some of the city somewhere here, perpendicular to the center of the Earth, and 500 miles down, they put another stick like this. The stick they put perpendicular to the center of the Earth because they believe so. They did not even know about anything about the Earth, but they just believe that have to be round. So therefore, then they measure the angle here. They found it different. So they conclude that this one have to be the round. And they believe if you keep walking, on east or west or north and south, eventually you will come back to original. So now then they start to find out, try to figure out what the circumference of the circle, for example. So what they do is they observe somewhere south of Cairo, at certain time of the years, especially solstice season. So they observe, they dig a well straight down to the center of the Earth, and they keep recording. So whenever the whole sun here, inside of the well, the water here, and they know that they record that time, that is the sun perpendicular to the Earth, okay? So they keep that well here, and they come back to North Cairo, okay, to the north 500 miles from here. Okay, let's say here is a Cairo. So they put the stick right here, okay, right here, perpendicular to the Earth, and they measure the angle made with the stick from the sun, made with the sun. So this angle here, the record is about 7.6 degrees or something, okay, around that. So now, why is so important? Because when you connect everything to here, you connect it onto the center. So by parallel postulate, formula, you this angle here also equal that angle, which is 7.6 degrees. Okay, then they use the ratio. We just use the ratio to find formula radius times angle, right? But now we go backward. So they put like 500 miles over the circumference of the circle. They don't know, they not even know the formula is 2 pi r at all. They just knew it. They think that this one have to be the sphere, the round, the Earth's round. So they put this one over this one have to be equal 7.6 degree over 3.6 degree. See that? So then they solve a circumference, and they know the circumference accurate to the 98%. They have only 2% error. So, well, then later on we can find a little bit faster. Okay, so now we know the formula angle is the length of circular arc S equal theta times r, right? So now how we know S here, which is 500 miles, okay, mile, and theta equals 7.6 degrees. We have to change to radian. So 7.6 degrees times with pi radian, pi rad, divided by 180 degrees, because pi equal 180 degrees. So when you want to change the degree to radian, radian should be on top because you cancel that degree here. So it turned out to be, you use a calculator, you take this one, you times pi divided by 180, you have, then you know the angle, okay? So therefore, if you know the angle here, you divide by the angle, you get 500 divided by the angle theta here in radian here. So we're going to get the radius very accurate into 98%, okay?